Hello, everyone. Welcome. Thank you for joining us today. I am Michael Mitchell, Project Manager for the Coalition of Rainforest Nations. This is now our fourth session of our webinar series of 6, building up to COP26 in Glasgow, Scotland. Today we will discuss where are we going, understanding the Paris Agreement through science. If you have questions during the interview, please use the raise hand option at the bottom of your screen or put them in the chat and we will address them at the appropriate time. Please be advised this will be recorded for future training use. The purpose of this series was to provide a scientific background from the IPCC reports and also political decisions already taken at previous COP summits and to build awareness around where we currently stand with the climate emergency. In addition to this, we wanted to show how scientific results contribute to the negotiating process we see at COP26 and how they'll affect the global stocktake under the Paris Agreement in 2023 and other processes thereafter. After an introduction of the IPCC in the first webinar, the second one addressed greenhouse gas emission trends. What are the main drivers of these emissions and implications of their growth? All of this was based on observations from independent sources, including satellite data, and provided the foundation to respond to the question, where are we now? Today, we hope to provide some insights into what are possible the climate futures we can anticipate, based on projections from climate models that assume scenarios of future developments of drivers of climate change and global warming. I'm joined here today with Vice Chair of the IPCC and Senior Technical Expert at the Coalition for Rainforest Nations. Thelma will be guiding us through projections of how future emissions can evolve and their impact to global warming.
Yes, thank you, Michael, and hello, everybody. And it's really nice to be here again. So, Michael, I guess that the easiest way to start our conversation today is to show a slide from the new report from the IPCC Working Group 1. The authors have assessed in the literature 5 scenarios of future emissions that cover the range of possible future developments of anthropogenic drivers of climate change.
I see that each one has a different label. Are there specific meanings?
Yeah, each scenario is labeled SSPXY. So SSPX refers to the shared socioeconomic trends underlying the scenario, and Y refers to the level of radiative forcing resulting from the scenario at the end of the century.
Can you explain what radioactive forcing is?
Yeah, sure. So you remember in our last webinar when we talked about incoming solar energy and outgoing solar energy and how this energy flux could be changed by a driver, for instance, the increase in carbon dioxide concentration in the atmosphere. So the strength of a driver, how much it contributes to change the energy flux, is quantified as radiative forcing and is expressed as watts per square meter. So the effect of a radiative forcing of 8.5 watts per square meter, as we have for scenario SSP5 8.5, would be similar in terms of warming as if you would place a bulb of 8.5 watts in every square meter on the ground.
So this would be the scenario with the highest emissions, is that correct?
Yeah, from the 5 scenarios that have been assessed by the IPCC, Michael. So you see that for different scenarios, the radiative forcings are different and obviously have different implications to the warming. So the scenarios with the lowest radiative forcings are those with very low and low greenhouse gas emissions, followed by an intermediary scenario, and then 2 scenarios with high and very high greenhouse gas emissions.
With these different emission scenarios, what would be each of their effects to the actual global warming?
That's really a good question, Michael. The authors have assessed how the climate would respond to the different scenarios. And this next slide clarifies their effect on warming above pre-industrial levels. So with these scenarios, well, let's take an example, the SSP 1.9. Okay, so you see 4 bars for that scenario. 1 for the total warming. And note that the darker shade shows where we are today, 1.1 degrees Celsius. And then the next bar shows the contribution of CO2 to the total warming. The next bar, the contribution of non-CO2 greenhouse gases. And finally, the last bar, the contribution of aerosols in land use, which have a cooling effect. So this is why they are below 0 there.
So the expected warming for here is approximately 4.5 degrees Celsius in this scenario.
Well, yes, that's the best long-term estimate from 2008 to 2100. But IPCC also provides best estimate for other periods that are not shown here. But for instance, for the period 2041 to 2060, the best estimate is 2.4 degrees Celsius. And for where we are now, 2021 up to 2040, the best estimate for this scenario is 1.6 degrees Celsius.
It seems like the total warming in each of these scenarios, except for the first, are far from the 1.5 degrees Celsius goal as pursued in the Paris Agreement.
Well, indeed. And you will be even more impressed seeing how the changes in the global surface temperature are projected to be distributed in the globe for 3 levels of warming, 1.5, 2, and 4 degrees Celsius. So in this slide, you can see that for some regions, the warming will be larger. Look at the north part of the northern hemisphere, where the increase in the temperature can be 2 to 3 times more than the global average. And also differentiations of the temperature increase even within a same region.
This is very interesting. If you don't mind, I want to go back to this slide. I notice here that the emissions become negative and they are below 0. Is this possible?
Yeah, that's all that gray area that you see below 0. So those are the negative emissions that we will talk to. But this is really a good question, Michael. And let me explain, because we hear a lot about negative emissions. So what really do we mean by this?
Yes, I'm very curious.
Okay. So I will illustrate the concept of negative emissions with a slide from the IPCC Special Report on Global Warming of 1.5 degrees Celsius of 2018. So that report assessed CO2 emission pathways, or if we wish, trajectories, that would limit global warming at 1.5 degrees Celsius above pre-industrial levels by the end of the century. In all the pathways assessed in the literature, the CO2 emissions were reduced to net zero globally around 2050. This is for limiting global warming to 1.5. So this slide shows the envelope around the assessed CO2 emission pathways, all of them leading to 1.5 warming by 2100. But those CO2 emission pathways shaded in blue, we will achieve the 1.5 by the end of the century without overshooting the temperature. That is, without temporarily exceeding 1.5.
And how about those emission pathways shown in gray here above the blue?
Well, these relate to overshoot pathways that exceed 1.5 degrees Celsius before the end of the century. Some of these pathways are referred to as pathways with limited overshoot, when the temperature exceedance is less than 0.1 degrees Celsius. And others are referred to as pathways with higher overshoot.
How can the temperature possibly come down to 1.5 degrees Celsius once it exceeds it by the end of the century?
Well, that's an interesting question. And that's when I think we will explain the negative emissions here. That's when they really come in. So when the difference between CO2 emissions and removals is negative, that is, when you have more CO2 removals than CO2 emissions, that is what we refer to as negative emissions, right? So, and this is what you can see for the low and very low emission scenarios for around 2050 and 2007, when they start dipping into the negative emissions.
I think I understand. Now, how can removals be achieved?
Yeah, there are several ways to remove CO2 from the atmosphere. Among them, I would cite reforestation and afforestation, bioenergy with carbon dioxide, carbon and storage. So if these activities are implemented at large scale, then removals can exceed the emissions and negative emissions would result. You may have heard about carbon dioxide removal CDR options or measures. These are all meant to remove CO2 from the atmosphere, including the two examples I just gave. But other options also exist, such as ocean fertilization, biochar, direct CO2 air capture, among several others. So most of the trajectories with limited or higher overshoot use CDR options at different levels, depending on the overshoot.
So let's move from this topic and talk about the net zero CO2 emissions that you mentioned. How can this be achieved? How can CO2 emissions be zeroed when they are the most abundant greenhouse gas in the atmosphere and are related to so many activities in all our lives?
Well, thanks. As I mentioned, net zero CO2 emissions will be needed, not only to limit global warming to 1.5, but to any level of warming. So the difference is on the timing when this needs to be reached, and is directly related to the accumulated CO2 emissions in the atmosphere. For 1.5 degrees limit, this is expected to be around 2050, as we mentioned. So now coming to your question on how we can do this, it's a huge challenge. And indeed, IPCC in the global warming report has already indicated that unprecedented changes, I would say transformational changes really, are needed in all areas of the society. So system transitions in energy, agriculture, land use, waste, industrial processes. So also the negative emissions we talked about, they could help compensate for some of the residual CO2, those CO2 emissions that could not be zeroed. So the negative emissions also play that role.
Thelma, why do we talk about net zero CO2 emissions, but never mention net zero greenhouse gas emissions?
It was my fault, and you're absolutely right. Although we say that we don't foresee that the non-CO2 greenhouse gases emissions are zeroed, right, as in the case of CO2. But in particular, methane, nitrous oxide, and other non-CO2 are expected to undergo strong reductions in parallel to the CO2 reductions. But you know what? Some of these reductions, like methane reductions, also contribute to improve air quality. And obviously, this has a direct effect on health and also could avoid some respiratory diseases. So this is good to know because you're not only doing it for climate, you are doing it for other things as well.
Doing it for your health.
Yeah.
So if global net negative CO2 emissions are achieved and sustained, would the increase in the surface temperature stop?
Well, not really. the global CO2-related temperature increase would be gradually reversed, but other climate changes would continue in their current direction for decades to millennia. For instance, it would take several centuries to millennia for global mean sea level to reverse course, even under large net negative CO2 emissions.
And we know that the ocean takes up approximately 25% of the annual CO2 emissions released to the atmosphere, and that is the cause of the ocean acidification, for instance. So if the global net negative CO2 emissions were to be achieved and sustained, what happens to the ocean acidification?
Well, in this case, it would reverse the surface ocean acidification. And this would really be helpful to the corals. Everybody knows that acidification is promoting all these changes in the corals. Right now, not even at 1.5, we are talking now a big effect on the corals. But so we think that this will be reversed, but this is why IPCC indicates in the last report that some of the changes can be slowed and others could be stopped by limiting warming.
Out of curiosity, Thelma, what does the IPCC say about limiting global warming in their new report? Is it still feasible?
That's a million question, $1 million question. And that,
So we all want to know.
Yeah, well, well, and this last report that was just released, bring so much more information into this. And so you have to be patient because I'm going to respond to your question in parts, okay? So for each scenario, I'm going to tell you how we are in terms of limiting global warming to 1.5. Okay, so under the intermediate, high, and very high scenarios, the last three top, global warming of 1.5 degrees would be exceeded during this century. So no way. So from now until 2040, okay? So let's see what can happen in terms of the 1.5. So we have chances here, probabilities, right? Or likelihoods, as we like to say in the IPCC. So to be simple, I'm going to say the chance. So from now until 2040, the chance is more than 90% that 1.5 degrees Celsius will be exceeded under the very high scenario. Now, until 2040. So that is really, really critical. Under the intermediate and high scenarios, this chance drops, right? So it is more than 66% that 1.5 will be exceeded. For the low emission scenario, the second one from bottom up, the chance is more than 50% that 1.5 will be exceeded. And under the very, very low scenario, the chance is more than 1.5, that is more than 50% that 1.5 is reached. So previously we were talking about exceeding. Now we are talking about is reached. So also for the very low scenario, there is more than a 50% chance that the global surface temperature would decline to below 1.5 towards the end of the century. So with a temporary overshoot of no more than 0.1 degrees Celsius above 1.5 global warming. So as IPCC says, Michael, if we do not have rapid, strong, and sustained emission reductions, even reaching 2 degrees Celsius might not be possible. And we already know that this half degree between 1.5 and 2 makes a whole lot of difference. So the IPCC assesses these differences. It compares 1.5 to 2 degrees. And well, wow, you can see changes there. So it would be much better for the planet if we could go to the very low greenhouse gas scenarios or the low scenario. to be on the safer side. Thank you very much, Michael.
Thank you. We have a lot of work to do. Well, I know I asked you a lot of questions. If there's any other questions, please go ahead and let us know. Thelma, thank you so much for helping me understand where we currently stand on the climate crisis and what future scenarios we can anticipate. I definitely learned a lot once again from you. I hope everyone else did as well. So if there are no further questions, I wish you all a great weekend. Thank you for all your contributions in fighting global warming. Again, we are all in this together. Take care, and we hope to see you next week for our final webinar of the series, Open Issues at COP26, Article 6 and Transparency, the critical steps needed towards a successful summit. So again, thank you everyone. Have a great day, and we'll see you next week. Thank you, Thelma.
Thank you, Michael. Thanks, everybody. Bye-bye.